Welcome back, everyone. This is part 3 in our series on supervised sentiment analysis. This screencast is going to focus on the Stanford Sentiment Treebank. We start with a quick project overview. The associated paper is Socha et al. 2013. And I think this paper is a kind of model of open science. At this website here, you can see the full code, all the data, of course, as well as an API that will let you try out new examples and kind of interact with the core models that are motivated in the paper. It's a sentence level corpus. It's got about 11,000 sentences in total. And all of those sentences are originally from Rotten Tomatoes. So they are sentences from movie reviews. The sentences themselves were originally released by Pang and Lee in 2005. It's kind of classic data set. And what the SST did was expand the data set by labeling not only the full sentences, but all of the subconstituents according to a kind of traditional parse, syntactic parse of each of the examples. And those are all crowdsourced labels. So what this means is that we have vastly more supervision signals all throughout the structure of these examples than we would get from the original, where we just had a single sentiment label for the entire sentence. The labels themselves in the underlying corpus are 5-way labels that are extracted from workers' slider responses. So there's kind of an initial layer of aggregation. They made a slider choice. They were all grouped together into 5 labels. And then we are going to work with a formulation that is even more collapsed down to ternary sentiment. I'll return to that a bit later. The fully labeled tree thing is one of the really exciting aspects of this corpus that we will be able to take advantage of, especially during training. So the way that worked is there were parses. This is a simple constituent parse of the sentence NLU is enlightening. And as I've indicated here, we have labels in that space 0 through 4. On all of the lexical items, NLU is and enlightening, as well as the altus subconstituents in this phrase. And so you can see that is neutral, but since enlightening is positive, the whole verb phrase is enlightening is positive. We can say that NLU is neutral, but in the context of this sentence, the overall contribution is a highly positive one. So label 4 on the root. In the first screencast for this unit, I motivated sentiment analysis with some cases that I thought were kind of difficult from a syntactic point of view. This is one of them. They said it would be great. I love how this is being handled. We can see that down here, be great is kind of clearly positive. But by the time we have filtered that through this report, they said, which is kind of displacing the sentiment onto another agent. The speaker is not necessarily endorsing the claim of greatness. What we get in the end is more like a neutral sentiment. I think that's interesting. And we can extend that even further, right? These are actual predictions from the model that's motivated in the underlying paper. If we take that constituent that I just showed you and conjoin it with they were wrong, which is clearly negative, strikingly, the model is able to figure out that the overall sentiment is determined by this second clause here and assign negative to the entire thing, despite the fact that there are obviously subconstituents in here that are positive. And that's exactly the kind of mixing that I think is correct for how language works in the domain of sentiment. And it's kind of encouraging to see that this model is able to capture at least some aspects of it. Here's a similar case that I think is pretty good as well, although maybe not as strikingly positive in the end here. I've just changed from the previous example, they were wrong to they were right. It knows that right is correct, and it seems to get that this is kind of middle of the scale. I might hope this was a 3 or a 4, but I think that still we're seeing some interesting interactions between what's happening in subconstituents in these examples and the prediction that's made at the root level. So it's very encouraging. There are a bunch of ways that you can formulate the SST task. Kind of the raw one that comes from the paper would be a 5-way classification problem where we'd have these numerical labels here with the meaning of kind of 0 is very negative, 1 is negative, 2 is neutral, 3 is positive, and 4 is very positive. I think this is fine, but there are 2 gotchas underlying this kind of scheme. First, it's not really a fully ordered scale in the sense that 4 is stronger than 3, but 0 is stronger than 1 because we have this kind of polarity split with neutral in the center. So that's a kind of conceptual difficulty. And then the other part is that by and large, classifier models that you pick will not give you partial credit for being close. We might hope that a model that predicted a 1 negative was kind of right, or certainly more right if the true label is 0 than a model that had predicted 4. But of course, if these are all treated as independent classification bins, then you'll get, you're just equally wrong no matter which prediction you made relative to the gold label. And that seems kind of unfair to our models. We are going to work with what I've called the ternary problem. I think this is the minimal problem that really makes sense conceptually. For this one, we group 0 and 1 into a negative category, 3 and 4 into a positive category, and reserve 2 as before for what we're calling neutral. And this kind of avoids the false presupposition that every sentence is either negative or positive, because it does allow us to make predictions into this neutral or non-sentiment laden space. It's very common, and you see this in the paper as well as in a lot of work on the SST, to formulate this as a binary problem. For the binary problem, we simply remove the middle of the scale and treat 0 and 1 as negative and 3 and 4 as positive as before. I think that has two drawbacks. First, we have to throw away some data, and second, then we're making this false presupposition that every sentence is either classified as negative or as positive, when for a wide range of cases in the world, that might be inappropriate. Now, I focused here on the root level problem. You can see that the numbers here for train and dev are small, and the test set numbers are a little bit larger than for dev, so they're comparable. But we can also think of this as the all nodes task, because recall that a hallmark feature of the SST is that every single subconstituent in these examples has been labeled by crowd workers. So we could treat each one of those as a kind of independent classification problem. We have the same range for all of the values that they can take on, so we can do similar kind of collapsing down into the ternary problem or the binary problem. And of course, here we have a much larger data set. For us, we're going to, by and large, work with the data in one particular way, which I think is common in the literature. As I said, we're going to have the ternary formulation, so our labels will be positive, negative, and neutral. When we do the dev and test step, we are going to test only on full examples. So for them, we will not make predictions into the subconstituent space. And then as a default for the code, as you'll see, it is set up to train only on full examples. So for these two cases, NLU is enlightening and not enlightening here. If those were two independent sentences in the corpus, we would train just on those two independent examples, one negative labeled positive and the other labeled negative. However, you might imagine that you'll get a lot more strength in training if you also train on all the subconstituents, which would mean essentially expanding this example into its full root version, NLU is enlightening, but also all of the sub pieces that are captured and labeled in the corpus. So that would give you many more examples and much more diversity. And then, of course, not enlightening would be split apart as well. And then you could decide for yourself, in addition, whether you want to treat this as two instances of enlightening or one. And the code facilitates all this. So you can formulate it as a root-only training scenario or as a subconstituent training scenario, and you can keep or remove duplicates. This is going to impact the amount of computational resources that you need for training models. But of course, bigger could be better in this space because you're just seeing much more gold-labeled information. So that's the overview. And for much more on this and how to work with our distribution of the corpus and so forth, I would encourage you to work through this notebook that I've linked at the bottom here.